Hey, Nico.
Hello.
Jamie is also in the room. He has not unmuted himself yet, though. Um, looks like there is. Hey, Jamie. Good
Sorry
evening.
about that.
No,
I
no
did not
problem.
know.
No problem. We're all here. We can work on whatever you guys want to, as always. If you need a few minutes to get that set up, I'll just stand by and wait for some stuff to help you guys work through.
I don't have much of questions for descendant, but I was wondering if we could go over like solving matrices by hand and stuff like that.
Sure.
Just because, yeah.
Sure. Nico, where do you stand on things?
I'd like to do that too. I also sent you 2 problems, I think, for right now.
Okay. Jamie, are there any 3x3 systems
I
that you
don't
got,
think
or
we're gonna have to solve any by hand for 3x3.
so just 2x2?
Yeah, correct me if I'm wrong, Niko.
No, it's
It's just
3x3s
2x2,
by
right?
calculator, 2x2s by hand.
Yeah.
Okay. Very good. Okay. Let me start with 38, and then I'll do a 2x2 by hand.
That works.
39, I'm gonna have to look up. I have no idea what it's asking for. So, and actually maybe somewhat the same with 38 here. I think. So let me share my screen and we'll get started here. All right, guys, so we got a determinant, use determinant to find the area of the figure with below. I guess this is a triangle. Do you guys know, or have you looked
Oh, no.
to decide that? Like sometimes you can graph that. I mean, there's 3 points, so assume it's a triangle, but you can sometimes you can graph and it's actually a right triangle. You don't need to use matrices. But let me look for the formula of this. It's usually like yeah, here it is. I remember us doing a problem like this, and it's like a pure formula. Although, let me find a good one. Here it is. All right, so here is your formula. You would have to know this to be able to do it. Here's your x1, your y1, x2, y2, x3, y3. So it's 1/2. These lines right here mean determinant, and we'll get to that in a moment. So it's minus 6, 3, 1, 6, 6, 1, and then 4 minus 2, 1. Will you guys be allowed to use a calculator for a problem like this?
Yes.
Okay, so grab your calculators. While you're doing that, I'll look for a 2x2. We can couple those, we can solve by hand, but you want to get the determinant of this matrix here. And that'll give you your area. And if you're not getting the right answer, I will definitely use my calculator and compare results with you guys.
You have to divide it by 2 at the end or no?
Yes, 1/2, multiply by 1/2, divide by 2, yes. All right, so very simplistic system here. 2x plus y equals -7 minus x minus y equals 6. This system is a very simple solution to it, but we can talk about how you might use matrices to solve it. Let me know when you're ready to get up to here.
I'm ready.
Okay. All right, so the one path here is you write the coefficient matrix for X and Y. And then you write the right-hand side here. Okay, and if you're truly using matrices, you have a system in this form, AX equals B.
Mhm.
Okay, and then the solution is X equals A inverse times B. So that's option one. Second option is to use reduced row echelon form, or what's called Gaussian elimination. So when you said, hey, I got to do these by hand, do you remember which one you meant? Like option one, option two, or both?
I think option 2 is the one.
Okay. So option two, we would actually not write quite like this. We'd actually write what's called the augmented matrix first, which is 2, 1, -7, -1, -1, and 6. This is considered the augmented matrix here. So it's the coefficients, then the right-hand side. So the first thing you do is you're trying to get this, your goal, let me write your goal over here to the right. Your goal is to get this down into 1, 0, 0, 1, number. Alternatively, you can get this down into 1 number, some other number, 0, 1 number, and that's also enough to solve it. So we'll talk about how to do that here in a moment. So there's a lot of ways to start here. If you do like 2 times row 1 plus row 2, when you multiply row 2 by 2, you get a -2 in this first position. When you add it to row 1, it becomes a 0 there. And in this case, we actually want to make the result of this row 2. So you put the result wherever you want, is I guess the point. So like let me try to show this here. So it's 2, 1, -7, and then when you multiply row 2 by 2, you get -2, -2, -12, and then we add them together, you get 0, -1, -19. Is that right? That doesn't seem right.
Yeah.
This is +12. Sorry. So that's +5 down here. Okay, so that becomes your new row 2. So you keep your row 1, 2, 1, -7, 0, -1, 5. Okay, so our goal is to get a 1 in this position down here. So you now take your row 2 and you multiply it by -1, and it becomes your new row 2. So you keep row 1. So it's 2, 1, -7, 0, 1, -5. And this second line here, this right here means that y equals -5. Okay, so you have a choice here. You can either write the equation for row 1, or you can keep going here with Gaussian elimination. So if you multiply row 2 by -1 and you add it to row 1, and this becomes your new row 1. So your row 1 is 2, 1, -7. Row 2 times -1 is 0, -1, 5. When you add them together, you get 2, 0, -2. So this is your new row 1, 2, 0, -2. And then you keep your old row 2, 0, 1, -5. Okay. And then you can then take row 1 divided by 2, become your new row 1. So then it's 1, 0, -1, 0, 1, -5. And this tells you that X is -1 and Y is -5. Okay, and that is the answer to that one. So is that really what you guys wanted help on? And if I want, we should do another example, or have you guys do at least one also.
Could we work on? Wait, think. I'm trying to find one from a past test right now.
Yeah, this is a very basic one, so it's not, I didn't make it very hard. I got harder ones here if we want them.
What about
But-
one where you have like a matrix you already set up, but it's got like shoot, like an X value in it, and you have to solve for X, but not like that.
So like sometimes there's problems like this where it's like X, Y, X plus Y, Z. And it's
Yeah, like
like, it's like 4, 3.
that's
And then,
yeah, that's what I was thinking.
yeah, I mean, these are hard for me to set up, but like, you know, you set like this equal to this equal to this equal to this, and this equal to this. Now, in my example, there's no system, but it could be. It could totally be a system here. So do you have one, or do you want me to look for one like that?
I think I might have one. I just the second part to the test that I'm not finding in my binder.
Nico, can you help here at all to find?
Which test is it?
Chapter 7 one.
I think I might have it. Let me find chapter 7. Oh, I have it. I found it. I'll take a picture of it.
Yeah, I cannot find it.
Nico, did you
I
say you found it?
Yeah, I
Okay.
found it. I'm
Okay.
sending it over to you right now. Okay, I just sent it.
Right. Okay, there it is. I do see that there's a solution to the second one we can look at, but yeah, let's look at this one first. All right, let me grab this image. Yeah, okay, this is a good one for us to look at. Let me download it, open, rotate, rotate, there it is. Okay, so this really does follow from the previous scribble that I made here. You're going to write a system by setting like top left equal to top left, top right equal to top right, and so on. Now there's 1, 2, 3, 4 variables. Okay, so we're going to leave room for them. It's A minus B equals 7. B plus C equals -1. This one's out of order, but we'll go C plus 3D equals 8, and then 2A minus 4D equals 0. Now this is bigger than a 2x2, but you can do some things to like make it nice, I guess. We can do this by hand, I guess is what I'm trying to say. Is that the goal here? Jamie, is that what you'd like to accomplish?
We can do it by eye. I'm just not sure how you set this one up, even with a calculator.
Okay, so in a calculator, let me write what's missing. 0C, 0D,
Mhm.
0A plus 0D, 0A plus 0B, 0B plus 0C.
Oh, and you said the 0. Oh, okay.
Yes, so you need a 4-row by 5 column, and you're just writing the coefficients. So 1, -1, a lot of zeros, 0, 0, 7, 0, 1, 1, 0, -1, 0, 0, 1, 3, 8, 2, 0, 0, -4, 0. Reduce row echelon form of that matrix, and you're done.
Got it. Okay.
All right, so Niko, let me jump back to the question you were asking me about this. I want to sign in. That's what I want to do. All right. So I just need 30 seconds, guys. I gotta log into something here to be able to look at this.
Okay.
I am about to get to where I can actually help you guys with this one. It's probably some sort of a determinant, but let me confirm that. To reset the password, and then I had to get a code, and now it's good. Yeah, so, yeah, et cetera, et cetera, et cetera. So in short, I finally have it here up. I think if it'll that's it's just not. Oh boy. Oh wow, there's a lot here. Okay. Uncoded matrices. The code matrix obtained. 935. Is there some words that go along with this one? They look.
It just says,
Oh, happy birthday.
yeah.
So we have to take happy birthday, and we have to iceberg dead ahead. Okay. We have to turn happy birthday into the letters of the alphabet.
Okay.
So let me do that here. with your help. So we want to like H, and you do this in threes. So we need HAP, PP, PYB, IRT. Geez. What do we do if it's not the same length? Man, this is a uncoded iceberg. Oh, they want zeros in between. Okay. So we're gonna go H, A, P, P, Y, and then space, which is gonna be a 0. B, I, R, T, H, D, A, Y, and then I guess we'll leave a space at the end. So we gotta get the letters for these. So let me go find a alphabet by number. All right, so I'll save you the excitement here. H is 8, so we need 8. A is 1, P is 16, so that's one of them. And then P, we just have a 16, Y is 25, 0. And then B is 2, I is 9, R is 18, T is 20, H is 8, D is 4, A is 1, 25, and 0. So the next step is to take each of these and multiply them by the A. So it's going to look like this. It's like 816 times or 16 times this A. Okay, and then you do 16, 25, 0 times this A. And you repeat. So you keep going here. So each of these 3 letters you repeat, and then the numbers you get out of this, you're supposed to enter in into the box. So like I'll do the first one here. Let me get A entered. 3, 3, 1. -2, -2, -7. Okay, so that's A. So we got that. 2, 3, 4, 3, 3, 1, -2, -2, -7. Okay, so then you're going to do your 8, 1, and 16 times A, and that gives you, well, that's not good, -13, -5, -79. I guess it is okay because it just wants the numbers. So let me just double check here. Yeah, so you do this for each of these. Iceberg, space, dead, space, ahead. Okay. Yeah, so you take each of these 3 letter sequences, and what you put in the box is starting here. And then we have to fill them in, the rest of them.
Got it. And then, all right, okay, got it. Perfect. Let's see if it works.
Happy space birthday space 1, 2, 3, 4, 5, 6, 7, 8, 9. Does that work, Nico?
Typing it in right now.
Okay. Jamie, you probably have a similar one, or maybe you already got it, but
Yeah, mine's similar. I'm just writing in right now. Yeah, mine works.
great. I don't think you will get anything like this on your exam,
Probably not.
but
Hope not.
it's a little odd.
Let's see. Yeah, it's correct. Perfect.
Great. I'm glad that worked. You guys are really good math students to be able to just take kind of this start and do it on your own here. A lot of people would really need help hand holding through the whole thing. So I'm glad you guys could do that. What else can we talk about or do, or more by hand 2x2s?
I have a 2x2
Um,
matrix on our WebAssembly. That's kind of confusing. Can I send that over?
Of course. Yeah.
The 36 one, Niko, or which
Yeah,
one?
that's exactly it. Yeah.
You guys always send me problems that are odd, not just, here's straightforward ones, but we'll look at them together.
Oh, wait. I might get it actually.
I think I just sent it over to you.
Okay, yeah, this is it's kind of a backwards problem, such that B equals A inverse. Right. So we need to take the inverse of A, like that's kind of the place that I would start here. So the inverse of A, you have to find the determinant of this of A, and then you do a 1 over that. This is formulas though. Oh, is that okay, guys, if we do formulas, or do you want to do it a row echelon form?
That works.
Either way works.
Okay, this is preferred. So it's the determinant is -15 minus a -4. Okay, 1 over that. So that's where you get the 1 over -11. So then if you're given A, B, C, D, the inverse is 1 over the determinant of it. And then you do some things. I believe you flip D and A. And then you negate B and you negate C. And so if you looked at B without if you factor in 1 over -11 in each, you would have 3, -1, I'm sorry, +1, -4, and you would see that this should be -5 down here. So K is -5 times this, so it's going to be 5 over 11.
Okay. Okay, it's right. I'm just gonna write the notes and what we did.
Jamie, are you getting the notes? I sent them to your school email.
Yep.
Okay, great. Probably want to remember this formula for tomorrow. It does save you some time. If you have a calculator, you can do it, but then you have to make sure to convert it to a fraction to get those.
Okay, I finished writing down the notes.
Great. Jamie, anything else here for us to look at?
I guess if maybe you have any I guess the only thing I could probably ask about is what's the best way to recognize how to set up these from a word problem, like a matrix.
Yeah, you guys had a good one yesterday, where there's usually a total, like X plus Y plus Z equals some total amount. And then there's usually, then the rest of them are constraints, typically. And some of them are where you are relating like one to the other. So a constraint would be like x plus y has to be, 1/4 of the total.
Mhm.
And a related relation, actually sometimes I call these relations. It's like z is, 4 less than y.
Okay.
But there's generally always these. So like, in terms of like your problems, like sometimes there's always a money element or a weight or a size. But if you can't set it up, you obviously can't do the problem. So you have to look very carefully at them. The ones in WebAssign are very tough. I don't know if your exams are that tough. Do you recall from any of your old exams, like were they mixtures of like,
Yeah.
walnuts and pecans, or
There was one on the.
sometimes they have
Or is it-
acid problems that are a little more complicated. 100% acid mixed with water to get a 50% acid solution. And those are like the constraints or the mixture type.
We had one about like a flower shop on our test.
You divide it by 5 and nobody.
Yeah, it was really weird. It was like, here, I'll send over the problem to you, actually.
Okay.
So you can explain it better.
Just because it was 5 bouquets or something.
Sometimes you have to know something intrinsic, like a pizza's 8 slices in this pizza shop, or like you said, bicycle has 2 wheels and a tricycle has 3. Sometimes there's little things like that, little nuances that differentiate it from being an easy problem to one's like, well, I can't solve this. So let's take a look at a couple or one here.
Okay, so I think I sent it over to you.
Okay, great. There it is. All right. All right, so let me download this. Rotate. All right, so here we go. I got the snipping in the question here. Florist is making 5 identical bridesmaid bouquets for wedding. She has $600 to spend and wants 24 flowers for each bouquet. Roses. Tips, lilies for each bouquet. Okay. Okay, so she's making 5 bouquets and she wants 24 flowers in each bouquet. So the way I understand that is, like, let's say roses, it's R, all the roses plus all the tulips plus all the lilies is 5 times 24. Because there's 24 in one bouquet and there's 5 total, and all the roses make that up. That's I guess maybe kind of one of those like interpretive statements. Roses cost $6, tulips cost $4, and lilies cost $3, and she has $610 for all of those. And then the second sentence, or third, she wants to have twice as many roses as the other 2 flowers combined in each bouquet. Okay. See, messing that up pretty quickly here. So roses has to be double the other ones. But I guess the question is like, are we doing all of these in terms of the bouquet, or doing them in terms of the total quantity? So I think I heard something earlier, like everything needs to be divided by 5, and now I kind of see that. So if we do this in terms of a bouquet, we know that all the roses and all the tulips and all the lilies in one bouquet has to equal 24. And since we want to spend the same amount on each bouquet, we would divide this by 5.
Mhm.
And then this actually one doesn't really matter because whether you use the bouquet or the full amount, this still holds that it's twice as many of that. So I guess the question is whether to either do the bouquet or the total for this. And it's these first two equations that you would have to modify depending on how you wanted to do it, because yeah, because I divide the second by 5, now all of a sudden it's for one bouquet, and the 24 is for one bouquet. Whereas before 24 times 5 was the total, 610 was the total also. I don't know, is that helpful?
Yeah, that makes more sense.
I guess maybe.
Yeah.
It's a little odd, the thing, I mean, sometimes these get kind of intuitive, like there's going to be more roses than everything else. But I would still use a calculator for this, and I would move everything over to the left and solve the system, with a calculator. Do you guys want us to solve this one, or do you already have the answer? Move on to something else.
I think we have the answer. I
Okay.
think she gave it to us and went over the test. Yeah. Look, I have a question. I remember on one of the tests. I just need to find it.
Six, 32 and 12. Yeah, I guess that works.
I sent you another test question.
All right, let me take a look here. All right, there it is. Okay. The bungee jumper problem. Right. It's in here. All right, a bungee jumper is jumping off the bridge. It's got a height of 850 feet. Okay, so person's starting and they fall 820 feet, and then it rebounds up 60% of the height. Then they fall again. They fall all the way down, and it rebounds again, and so on. This is a geometric sequence. Okay, and if you remember the formula for that, it's an equals a1 r to the n minus 1 power. So the first time he falls, let's see, we got to be careful here. After 5 times falling, so that's the first fall. So an or a at the first fall is 820 feet, and then the amount you rebound is 0.6 n minus 1. So you either know this or you sit there and you calculate. You're like, okay, it's 820 fall 1. Oops, let me move that over. Make a little table here. Why is it doing that? So your fall 1, and then your second fall is 0.6 times 820, And then your next fall is 0.6 squared times 820. And so on. But this formula has it built in. So have you seen geometric sequences?
Yes.
Okay, all right. So the other variation on this is the like ball bouncing after you drop it off a tall building. So in this case, your number of times fallen is you want a 5, 820.6 to the 5 minus 1 power. Is that okay? Clear?
Yeah, that works. Like,
All right, great. All right, what else you guys want to look at? We got some more time if you want it.
check if there's any more and any tests.
Jamie, how about you? What else, if anything?
Don't know, actually. I'm looking back through these tests. Confusing. I don't really have anything else.
Yeah, I think
Niko,
I'm good too. Yeah.
your exam tomorrow?
Mine's Wednesday.
Okay.
Yeah, mine's tomorrow.
Always a good idea to check your calculators are charged up, extra batteries, stuff like that, if you think you need them. But all right, well, if
Thank
that's
you.
it, then that's it. Yeah, thanks, guys. Thanks so much for scheduling
Thank
all
you.
semester, and I'll see you next year if you guys need help. Thanks so much.
Thank you.
Okay, bye now.